In a world defined by visible borders and satellite surveillance, where every square inch of the surface is mapped and contested, a new frontier is opening, not in the stars, but in the silent, absolute darkness beneath our feet. This is the subterranean realm, a network of hidden passages and colossal chambers that represents one of the last uncharted territories on Earth. It is a world that has begun to attract the intense focus of scientists, strategic analysts, and governments, for it holds not just geological wonders, but the keys to water security, untapped mineral resources, and a record of planetary history so profound it redefines our understanding of time itself. For centuries, we viewed these spaces with mythic reverence or fearful superstition, as gateways to the underworld or lairs of forgotten beasts. But today, the narrative is shifting from folklore to geopolitics. The race to explore, map, and understand this hidden dimension is underway, a quiet competition for knowledge and resources that could shape the 21st century in ways we are only beginning to comprehend. To stand at the precipice of a cavern is to stand at the edge of a new kind of power, one measured not in territory, but in depth. The story of this frontier begins not with a bang, but with a whisper, with a force so gentle it seems insignificant, yet so persistent it can hollow out mountains from within. When we envision the creation of the Earth's dramatic features, our minds conjure images of violent, cataclysmic events, the explosive fury of volcanoes, the grinding force of tectonic plates, the sudden, ground-shattering rupture of earthquakes. Yet, the genesis of some of the planet's most magnificent and strategically vital landscapes, the vast karstic regions that underpin entire nations, is a process of almost imperceptible patience. The overall mood is nothing more than a single drop of rain. As rainfall descends from the atmosphere, it seeps through the topsoil, and in this journey, it absorbs carbon dioxide from the decaying organic matter, transforming into a weak solution of carbonic acid. This water, now armed with a subtle but relentless chemical power, continues its descent until it reaches bedrock. In regions across the globe, from the Yucatan Peninsula in Mexico to the sprawling karst fields of South China, that bedrock is limestone, a stone born from the skeletal remains of ancient marine life, from oceans that vanished hundreds of millions of years ago. Here, in the deep silence of the Earth, a chemical drama unfolds. Drop by patient drop, the acidic water lands on the limestone and begins to dissolve it. The process is infinitesimally slow, a microscopic erosion that removes just a few grains of rock over the course of a human lifetime. But time in this realm is measured in geological epochs, not human years. Over thousands, then millions of years, this quiet, persistent dissolution carves out fissures, widens cracks into conduits, and hollows out immense chambers that grow into vast, interconnected underground labyrinths. These are not mere holes in the ground. They are complex, three-dimensional drainage systems, subterranean watersheds that hold and channel the majority of the world's accessible fresh water. Control over these aquifers, hidden within cave networks, is already a point of silent contention in arid regions, making the science of speleology, the study of caves, a matter of national security. The drip of water, it turns out, is the architect of empires, quietly shaping the Earth in a process of profound and patient artistry that continues to this day. But the water's work is twofold. It is both a sculptor and a builder. Once the void is created, the dripping does not cease. As each drop of mineral-rich water percolates through the ceiling of a newly formed chamber, it hangs for a moment, exposed to the cave air. This exposure causes it to release a minute particle of its dissolved calcite, leaving it behind on the stone. The next drop deposits another, and the next another still. Over centuries, these microscopic accretions form icicle-like formations that grow downward from the ceiling, the stalactites. The water that falls to the floor below is not wasted. It deposits the remainder of its mineral load, creating upward-growing mounds of stone, the stalagmites. These formations are more than just nature's cathedral decorations. They are Earth's hard drives. Each layer of their growth contains chemical isotopes that record the precise climatic conditions of the world above at the moment of their formation. By analyzing cross-sections of stalagmites, scientists can reconstruct ancient rainfall patterns, temperature fluctuations, and atmospheric changes with astonishing accuracy, providing a baseline of planetary history that is crucial for modeling our climate's future. Every curve, every delicate stone needle, every massive column connecting floor to ceiling is a data point in a timeline so vast it humbles the human imagination. A story shaped not by catastrophe, but by the relentless creative persistence of dripping water. To enter this world is to enter a living library where the planet writes its own autobiography, one drop at a time. To stand inside a limestone cavern is to stand inside a timeline so vast it challenges the very foundations of human perception. In our fast-paced, hyper-connected world, we measure history in generations, political cycles, and fiscal quarters. But the clocks in this subterranean realm operate on a cosmic scale. These formations are not created within the span of civilizations. They are monuments to deep time, a geological concept so immense it renders all of human history, every empire, every war, every technological revolution, as little more than a fleeting flicker in the Earth's long, silent memory. Many of the world's most critical underground systems, from the sprawling networks beneath the mountains of Southeast Asia to the vital aquifers undergirding the American Midwest, began their formation millions of years ago. The process is an exercise in profound patience, a relentless slow-motion sculpting of the planet's interior. Water seeping into stone dissolves just a few grains of rock over the course of a century. Entire passages, now wide enough to accommodate armies, may have begun as hairline fractures in the bedrock when dinosaurs roamed the Earth, continuing their quiet, inexorable expansion through successive ice ages, planetary warming periods, and the entire turbulent saga of humanity. This geological patience has profound strategic implications. The slow formation of these networks is directly linked to the creation of vast natural reservoirs, storing trillions of gallons of fresh water filtered to exceptional purity by the limestone itself. Furthermore, the same geological processes that create caves can also concentrate valuable mineral deposits. Rare earth elements, critical for modern electronics and defense systems, are often found in higher concentrations within these karstic landscapes. The global competition for these resources is, in essence, a race to understand and access geological formations that have been millions of years in the making. Some stalagmites in these caves grow so slowly that an entire human lifetime would not reveal even an inch of progress. These same formations hold within their crystalline layers a perfect high-resolution record of the planet's climate, a diary written in calcite that allows us to model future environmental shifts with unprecedented accuracy. To wander through such a place is to feel time stretch to its longest and most humbling measure, where the earth itself seems to breathe in an endless, powerful rhythm of patience and creation, reminding us that the most valuable resources are often those forged by the slowest and most enduring forces of nature. However, not all caves are born of water's patient artistry.
In the volcanic belts that ring our planet, the Ring of Fire, another, far more violent and rapid process forges subterranean landscapes. Here, the architect is not water, but fire. When a river of molten lava, incandescent and fluid, flows down the flank of a volcano, its surface is the first to encounter the cooler ambient air. This contact causes the outer layer to cool and solidify, forming a hard, insulating crust of basalt. Beneath this newly formed ceiling, the core of the lava flow continues to rage, a superheated artery moving downhill within its own self-made tunnel. When the eruption ceases or the main flow is diverted, the molten river drains away, leaving behind a perfectly preserved hollow tube. These are lava tubes, caves forged in the crucible of the earth, some stretching for miles underground. Their walls often retain the rippling, undulating patterns of the molten rock that once surged through them, a frozen testament to the fiery hydrodynamics of their creation. Unlike limestone caves that require millions of years to form, a complex lava tube network can be born in a matter of weeks, even days. These formations are no longer mere geological curiosities.
Today, they are at the forefront of strategic planning for off-world colonization. The lunar and Martian surfaces are bombarded by lethal solar radiation and micrometeorites, making surface habitats incredibly risky and expensive to shield. Lava tubes, which have been identified in satellite imagery of both the Moon and Mars, offer a ready-made solution: deep, structurally sound, and naturally shielded radiation bunkers. Space agencies like NASA and ESA are actively funding research into robotic exploration of terrestrial lava tubes as analogs for extraterrestrial missions, testing rovers and drones designed to navigate these environments. The knowledge gained in the lava tubes of Iceland or Hawaii could one day provide the blueprint for humanity's first sustainable off-world colony. They remind us that caves are not only the slow, patient work of water, but also the sudden, violent, and profoundly useful artistry of fire. At the dynamic edges of continents, where the immense tectonic power of the land meets the relentless energy of the ocean, a third type of cave is sculpted. Here, the primary force is kinetic, the ceaseless percussive assault of waves against cliffs. Over millennia, the sheer hydraulic power of pounding water, armed with abrasive sand and gravel, begins to exploit weaknesses in the rock, carving out hollows and alcoves. This physical battery is augmented by the chemical warfare of salt spray, which crystallizes within cracks, expanding and fracturing the stone from within. The result is the sea cave, a formation shaped entirely by the rhythmic, thunderous pulse of the ocean. Their entrances are often shrouded in crashing surf, their floors submerged at high tide, and their chambers echo with a permanent, deafening roar. In human history, these caves held immense tactical importance for coastal cultures. They were used as hidden shelters for fishing fleets, defensible smuggling depots, and clandestine bases for naval raiders. To this day, their complex acoustics can interfere with sonar, making them potential hiding spots for small submersibles. For geologists, they are living laboratories demonstrating coastal erosion in real time. For strategists, they remain a feature of the littoral battle space, ancient mouths of the sea, breathing with the tide and holding secrets shaped by water's indomitable power. Beyond the realms sculpted by liquid water and molten rock, we venture into the planet's cryosphere, the frozen domains where geology and glaciology intersect. Here, in the vast ice sheets of Greenland and Antarctica, and within the high-altitude glaciers that act as the world's freshwater towers, caves are not limited to stone. Ice itself, under immense pressure and in constant slow motion, becomes the host for a different kind of subterranean passage. These are not static formations, they are dynamic, ephemeral wonders born from meltwater.
This water, often warmer than the surrounding ice due to friction and pressure, trickles through the frozen mass, exploiting crevasses and weaknesses to carve out intricate tunnels that twist and wind like glassy arteries. To enter one is to step into a world of breathtaking and temporary beauty. Some ice caves glow with an astonishing, almost supernatural blue light, as the dense, ancient ice absorbs every other color of the spectrum, filtering the sunlight into pure, jewel-like tones. Others are pitch black, echoing only with the sound of dripping or rushing meltwater, a constant reminder of their own fleeting existence. Unlike their stone counterparts, ice caves are tragically mortal. A tunnel carved this year may collapse or be ground into oblivion by the glacier's inexorable movement the next. This fragility, however, is precisely what makes them invaluable to modern science.
The overall mood is frontline laboratories in the study of climate change. The layers of ice exposed on their walls are a high-resolution cryo-archive, a vertical timeline containing trapped air bubbles, pollen, and volcanic ash from millennia past. Analyzing this ancient ice provides a direct record of Earth's atmospheric history, offering critical data for understanding our planet's trajectory. Yet, as global temperatures rise, these frozen libraries are melting at an unprecedented rate. The study of ice caves has become a desperate race against time, a mission to extract priceless knowledge before these fleeting cathedrals of frozen light vanish forever, taking with them the secrets of Earth's climate locked within their glowing crystalline walls. Their disappearance is not just a loss of beauty, but a permanent erasure of planetary memory. From the frozen poles, our investigation takes us to the planet's most arid landscapes, where another seemingly gentle force demonstrates its power to reshape the Earth. While water and lava are the most famous sculptors of caves, even the invisible movement of air, when given enough time, can carve its own hollow realms. In the vast deserts of the world, where monolithic sandstone cliffs tower over sun-scorched valleys, strong, persistent winds become geological tools. These winds act as a relentless sandblaster, carrying billions of tiny, abrasive grains of sand that grind against the rock faces day after day, century after century. This constant, patient abrasion can wear openings into the cliffs, shallow alcoves that deepen and expand into true aeolian caves, caverns formed by nothing more than the power of wind. Their interiors are often smooth and flowing, with graceful curves that seem shaped by a careful artistic hand. But these caves are more than just geological curiosities. They are priceless archaeological archives. The overall mood acts as a perfect preservative, and within these wind-carved shelters, the remnants of ancient cultures are often found in a state of near-perfect preservation. Petroglyphs, pottery, and even the fragile remains of human habitation are shielded from the elements, offering an unblemished window into the lives of the people who sought refuge in these stone hollows thousands of years ago. In a modern geopolitical context, the very remoteness and defensibility that made them attractive to ancient peoples have also made them strategic assets for insurgents and non-state actors in contemporary conflicts, turning these quiet, wind-carved spaces into contested territory. To stand in one is to feel the air itself as both a timeless sculptor and a silent witness to the long, unfolding drama of human history. Yet perhaps the most alien and astonishing of all subterranean worlds are those where the cave does not just host formations, but becomes a geological womb for growing them on a scale that defies belief.
Deep underground, in chambers where mineral-rich geothermal water seeps through cracks and pools in absolute stillness, caves can become natural crystal gardens. Over immense timescales, under conditions of perfect stability, dissolved minerals slowly precipitate out of the supersaturated water, forming crystals that can grow to astonishing, unprecedented sizes. The most spectacular example known to humanity is Mexico's Cueva de los Cristales, the Cave of the Crystals. Discovered by accident during silver and lead mining operations, this chamber is a geological fantasy made real. It is filled with translucent selenite crystals, some reaching lengths of over 11 meters, longer than a city bus, and weighing as much as 55 tons. These are the largest crystals on Earth, glittering, frozen beams of light that crisscross the chamber in a dazzling, otherworldly matrix. This beauty was born from and is guarded by one of the most hostile environments on the planet. The cave is incredibly hot and humid, with air temperatures soaring to 58 degrees Celsius, 136 Fahrenheit, and humidity approaching 100%. Conditions necessary for the crystal's growth, but lethal to unprotected humans in minutes. Explorers must wear specialized cooling suits with their own air supply. Each crystal is a time capsule containing tiny fluid inclusions that are pristine samples of the ancient mineral-rich water from which they were born, a direct link to the planet's deep geothermal processes. The existence of such a place, a treasure chamber of both unparalleled beauty and extreme peril, serves as a powerful reminder that the Earth itself, in its darkest and most hidden corners, is still patiently weaving gemstones in the dark, creating wonders that surpass our wildest imagination. The perception of caves as static, unchanging monuments of stone is a profound misconception. They are not relics frozen in their final form upon discovery. On the contrary, many are dynamic, living landscapes engaged in a perpetual process of self-creation and destruction. In active limestone systems across the globe, the foundational processes of their birth continue unabated. Water, the lifeblood of this subterranean world, persists in its dual role as architect and artist. It continues to drip and flow, its weak carbonic acid slowly but relentlessly eating away at walls and ceilings, expanding chambers, and opening entirely new passages that branch off into previously solid rock. This ongoing dissolution is a critical factor in modern infrastructure planning. For nations with extensive karst geology, this constant invisible change represents a significant and unpredictable threat. The ground beneath highways, dams, and even cities is not as solid as it appears, but is being quietly re-engineered from below. The overall mood of dissolving stone in one area, it deposits its mineral load elsewhere, giving birth to new formations. Stalactites lengthen, stalagmites grow taller, and flowstones thicken their shimmering cascades of calcite. If one could return to the same cave after 1,000 years, it might be transformed. New pillars connecting floor and ceiling, old passages sealed off by collapses, and entire underground rivers rerouted into new channels. This constant slow-motion evolution makes caves not just objects of study, but active geological systems that demand continuous monitoring. To witness this is to see Earth's quiet, ongoing artistry, a powerful reminder that even that which feels eternal is always in motion, a silent, unfolding process with significant consequences for the surface world above. Sometimes, this process of subterranean change culminates in a sudden, catastrophic event on the surface. Not every cave remains a hidden, secret world. Over millennia, as an underground cavern expands, its ceiling can become progressively thinner, weakened by the relentless dissolution from below, until it can no longer support the immense weight of the rock, soil, and forests above it. When the breaking point is reached, the result is a dramatic and terrifying collapse, leaving behind a vast gaping depression known as a sinkhole. These events are geological trapdoors, sudden ruptures in the perceived solidity of the ground. While some are small and unremarkable, others are immense scars gashed into the earth, capable of swallowing roads, sections of forests, and even entire city blocks in a matter of hours. For scientists, sinkholes are invaluable windows into the hidden hydrology and geology below, exposing cross-sections of cave systems that were previously inaccessible. But for urban planners and the insurance industry, they represent a multi-billion-dollar hazard.
Natural male narrator with a warm, friendly tone. For a science podcast, fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.80. Human activity, particularly the over-extraction of groundwater for agriculture and urban centers, can dramatically accelerate their formation by altering the hydrostatic pressure that helps support cavern roofs. This turns a natural phenomenon into an increasingly man-made disaster, a stark reminder of the fragility of the ground beneath our feet. What seems solid and permanent may in fact be a thin veneer over a void, a secret held by water and time, waiting for the right moment to be revealed. While some caves reveal themselves by collapsing upwards, others command our attention by plunging downwards to unimaginable depths. When we think of natural grandeur, we imagine mountains reaching for the sky, their peaks dwarfing the world around them. Yet, hidden beneath the Earth's crust are chasms that extend downward even farther than many mountains rise upward. The deepest known caves on the planet plunge more than 2,200 meters, over 7,200 feet, a twisting, vertical labyrinth of shafts, waterfalls, and winding tunnels that explorers have dubbed inverted Everests. Descending into such a place is the ultimate test of human endurance and technology, a journey into absolute darkness and crushing psychological pressure. At these extreme depths, the very air changes, becoming heavy and stale, while underground rivers appear from solid rock, only to vanish into chasms so deep their bottoms have never been reached. The exploration of these super caves has become a new frontier of national prestige, akin to the space race. Expeditions to the world's deepest cave, Veryovkina in the Caucasus Mountains of Abkhazia, Georgia, are massive quasi-military undertakings that take teams of elite cavers weeks to complete. They require miles of rope, advanced closed-circuit diving apparatus for navigating flooded passages or sumps, and meticulous logistical planning. Here, in the disorienting, total blackness, explorers encounter colossal vertical shafts and the deafening roar of underground rivers. This is not simply a sport, it is extreme science. These depths are a unique laboratory for studying extremophiles, life that can survive under conditions of immense pressure and no light, and for understanding the deep hydrogeology of our planet. Standing at the bottom of such a place with over 2 kilometers of solid rock above you is to feel the immensity of the Earth's interior and the profound ambition of humanity to conquer the last, darkest corners of our own world. While the vertical descent into the Earth's abyss represents a brutal contest against gravity and fear, the exploration of its horizontal immensity presents a different kind of challenge. A battle against labyrinthine complexity and unimaginable scale.
If the deep caves are inverted mountains, then the Great Cave systems are subterranean continents. The undisputed titan of this realm is Mammoth Cave in the state of Kentucky, USA. It is not merely a cave, but a sprawling, multi-leveled underground nation-state of interconnected passages, the longest known cave system on Earth by a staggering margin. With more than 675 kilometers, 420 miles of mapped corridors, it is a living, breathing maze that continues to grow as new sections are relentlessly discovered by teams of dedicated speleologists. To comprehend its scale is nearly impossible. If laid out in a straight line, its passages would stretch from Washington, D.C. past Boston. But its significance extends far beyond mere size. As a UNESCO World Heritage Site and the centerpiece of a national park, Mammoth Cave is a major economic driver, fueling a regional tourism industry worth hundreds of millions of dollars. The overall mood has created a permanent, delicate tension between access and preservation, a challenge faced by nations worldwide as they seek to monetize their own subterranean wonders. Inside, entire ecosystems, isolated for millennia, thrive in the absolute darkness, including iconic species of blind fish and crustaceans that have become textbook examples of evolutionary adaptation. The decades-long, painstaking process of mapping this system, largely undertaken by volunteer researchers, highlights a profound human commitment to understanding the unknown. Mammoth Cave is more than a geological marvel. It is a global benchmark for subterranean exploration and a case study in the complex geopolitics of balancing national profit with planetary heritage. From the sheer length of these systems, we move to the breathtaking volume of individual chambers contained within them. Step into certain cave passages, and you might find yourself in a space so vast it dwarfs the grandest human constructions. These are the colossal halls of the underworld, rooms so large they feel more like captured voids of outer space than terrestrial caverns. Their arched ceilings soar hundreds of feet above, and their walls vanish into an impenetrable darkness beyond the reach of the most powerful lights. In these chambers, the laws of acoustics are transformed. A single human voice can be amplified into a ghostly chorus, with echoes lasting for many seconds as the sound waves bounce across acres of unseen stone walls. Some of these halls are decorated with massive stalagmites rising from the floor like the columns of a ruined alien temple. But the ultimate expression of this gigantism is found deep within the jungles of Vietnam, in a place known as Sơn Don Cave. First explored comprehensively only in the last decade, Sơn Don contains the largest known cave passage in the world by volume. The overall meant that a Boeing 747 could fly through its main chamber without its wingtips touching the walls. The ceiling soars to over 200 meters, 660 feet, high enough to accommodate a 40-story skyscraper. The discovery and subsequent management of Sơn Don have positioned it as a significant national asset for Vietnam, a crown jewel of natural heritage that has attracted global attention. The government, in partnership with exploration teams, has implemented a highly restrictive, high-value tourism model, limiting access to a few hundred visitors per year on expeditions costing thousands of dollars. This strategy aims to prevent the environmental degradation seen at other mass tourism sites, while maximizing economic benefit and asserting sovereign control over a globally unique landmark. The cave is so large that it has generated its own localized weather system. Clouds form near the high ceilings and produce rain within the cave itself. In 2 locations where the ceiling collapsed long ago, forming massive skylights or domelines, entire jungles have grown deep inside the earth, complete with trees reaching toward the distant openings. To stand within Sundong is to witness a self-contained subterranean world, an ecosystem, a weather system, and a geological event of planetary significance, all hidden beneath the remote mountains of Southeast Asia. Carving through and connecting these colossal systems are the hidden arteries of the planet, the underground rivers. Beneath mountains and valleys, surface rivers often vanish abruptly into limestone fissures, plunging into the darkness, only to reappear deep inside cave systems. These subterranean rivers can flow for countless miles, sculpting enormous channels, feeding vast sunless lakes, and even creating powerful waterfalls that thunder in the eternal night. Their waters, filtered by miles of rock, are often of an almost impossible clarity, untouched by surface sediments.
These rivers are the lifelines for the unique and fragile ecosystems that have adapted to the dark, and they are the primary architects of the caves themselves. For explorers, they represent both a path and a peril. They offer a route through the labyrinth, yet they can transform in minutes from a tranquil stream into a raging, inescapable torrent when a rainstorm occurs on the surface miles away. From a strategic perspective, these rivers are the core of the world's karst aquifers, vital sources of drinking and agricultural water for hundreds of millions of people. As surface water becomes increasingly scarce and polluted, the health of these hidden rivers becomes a matter of urgent national interest. Because they often flow invisibly across international borders, they represent a significant potential for future transboundary water conflicts, a silent, underground resource over which future wars may be fought. Fed by these hidden rivers are some of the most pristine and enigmatic bodies of water on Earth, the sunless lakes of the underworld. Hidden away in sealed chambers, these lakes have never once been touched by a single photon of sunlight. They exist in a state of perpetual, patient stillness, their surfaces often resembling perfect mirrors of black glass, undisturbed for centuries. Because they are completely isolated from the surface, they act as sealed evolutionary laboratories, harboring unique forms of life found nowhere else. These are not just ecosystems, they are astrobiological analogs of the highest order. The search for extraterrestrial life has increasingly focused on the subsurface oceans of moons like Jupiter's Europa and Saturn's Enceladus, vast bodies of water sealed beneath miles of ice. The sunless lakes of Earth's caves are our closest model for these environments. The life within them, often subsisting not on photosynthesis but on chemosynthesis, metabolizing minerals from the rock itself, provides a potential blueprint for what alien life might look like. To stand beside one of these underground lakes is to gaze into a crucible of evolution, where creatures have adapted to an existence without light, developing heightened senses of touch and chemical detection to navigate their silent, black world. Their waters, filtered to an extraordinary clarity by the surrounding limestone, are invaluable scientific assets, containing a chemical and biological record of a world sealed off from modern pollutants, a baseline of planetary purity that has been all but lost on the surface. The sheer scale of these subterranean voids extends beyond mere length or depth. It encompasses volumetric spaces that defy human architectural references. There are cave chambers so immense that their interiors could comfortably hold tens of thousands of people, functioning as natural, pre-built amphitheaters. These colossal halls, larger than modern sports arenas, stretch for hundreds of yards with ceilings that vanish into an impenetrable darkness overhead. Their strategic value has not been lost on military planners.
Throughout the Cold War, nations on both sides of the Iron Curtain identified and repurposed such caverns as hardened, subterranean military bases, aircraft hangars, and vast civil defense shelters capable of protecting entire populations from nuclear attack. The natural limestone provides a level of protection against ordnance and radiation that would be prohibitively expensive to replicate on the surface. Beyond military applications, their stable, vibration-free environments are now being leveraged for high-tech purposes. The constant cool temperature and isolation make them ideal locations for energy-intensive, secure data centers or highly sensitive physics laboratories, like those searching for dark matter, shielded from cosmic radiation by kilometers of solid rock. In the past, these caverns were sites of sacred ritual. Today, they are becoming bastions of strategic defense and advanced science. Natural cathedrals of stone repurposed to house the secrets and ambitions of the modern age. Within these vast chambers, the very physics of sound is altered, turning stone and air into a colossal musical instrument. The specific geometry of the chambers, the composition of the rock, and the subtle flow of air combine to produce extraordinary acoustic properties. A single shout can echo for an astonishing duration, its reflections bouncing between distant walls to create complex, ghostly harmonies. This phenomenon was almost certainly recognized and utilized by ancient cultures, who likely chose these resonant spaces for rituals, believing the magnified and reverberating chants were the voices of their gods. Modern science now studies this field as archaeoacoustics, analyzing how sound behavior may have influenced human spiritual development. In some chambers, dripping water strikes hollow stalactites of varying lengths and thicknesses, producing a random percussive melody akin to a hidden xylophone. The most famous example of this being harnessed is the Great Stalactite Organ in Luray Caverns, Virginia, where stalactites are gently tapped by rubber-tipped mallets to produce concert music. In other systems, strong drafts of wind are funneled through narrow passages, creating a deep, resonant hum like a planetary organ pipe. These natural acoustics are more than a curiosity. They are a reminder that these spaces are not silent. To listen within a cave is to tune in to the subtle, resonant voice of the earth itself, a deep and ancient music played on an instrument of stone. This subterranean music is often accompanied by the most powerful and dramatic feature of the underworld, the hidden waterfall. Deep beneath mountains, where underground rivers carve their secret paths, they sometimes plunge from the ceilings of high chambers into pools far below, thundering in the absolute darkness. The sound in a confined stone hall is overwhelming, a deafening, concussive roar that echoes until it feels as though the cave itself is alive and breathing. The constant spray from these cascades carves smooth, polished basins in the rock and creates zones of extreme humidity that support unique forms of life. For explorers, stumbling upon a major underground waterfall is a moment of profound sensory shock. The raw, violent power of crashing water, a phenomenon so associated with open skies and landscapes, is suddenly present in a place of utter confinement and blackness. It is a surreal juxtaposition of kinetic energy and geological stillness. The overall mood is relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The overall tempo should be around 0.80. While largely inaccessible, the immense and constant power of these waterfalls represents a theoretical source of untapped energy, a potential site for micro-hydropower generation to run scientific monitoring stations in the deepest, most remote parts of a cave system. These secret waterfalls are a visceral reminder that the underworld is not a static museum, but a dynamic, powerful, and living environment, alive with movement and a hidden, thunderous beauty. The physical laws that govern the subterranean realm can, under precise and stable conditions, produce wonders that seem to defy possibility. We return to the blistering depths beneath the Nika Desert in Mexico, home to the Cave of the Crystals, because it represents the ultimate expression of geological artistry. These are not merely large crystals, they are monumental structures of translucent selenite, beams of gypsum so vast they recalibrate our understanding of mineralogical growth. Their existence, however, presents a profound modern dilemma, a direct conflict between industrial economics and priceless natural heritage. The cave was discovered only because a mining company, in its pursuit of lead, zinc, and silver, was actively pumping water from the depths to keep its operations dry. This industrial activity lowered the water table, exposing the chamber and its crystalline titans to human eyes for the first time. For years, the continued existence of the mine was the only thing preventing the cave from returning to its natural flooded state. In 2017, when the mine was no longer economically viable, the pumps were shut down. The waters began to rise again, slowly reclaiming the crystal chamber. This has created an urgent, high-stakes debate. Is humanity obligated to incur immense expense to preserve a wonder that it only discovered through the very process that now threatens it?
The cave is also more than a geological marvel. It's a biological time capsule. Scientists have extracted and revived dormant microbes that were trapped within fluid inclusions inside the crystals for tens of thousands of years. It is a living link to an ancient microbiome, a potential source of novel biological compounds now being submerged once more by the forces that created it. Beyond such visible wonders, the cave environment harbors threats that are entirely imperceptible. The very air underground can be a silent and lethal variable. While often feeling cool and refreshing, a cave's atmosphere can hold hidden dangers. In many systems, particularly those with significant organic matter decaying within or complex interactions between groundwater and limestone, the concentration of carbon dioxide can rise to levels far higher than on the surface. For humans, this invisible gas can quickly cause disorientation, severe headaches, and, with prolonged exposure, asphyxiation. This is not merely a theoretical danger, it is a critical operational factor for both scientific expeditions and underground rescue missions. Elite cave rescue teams operate with the same level of atmospheric monitoring as hazardous materials units, as CO2, being heavier than air, can settle in the lowest passages, creating invisible, oxygen-deprived traps where even a simple ankle injury can become a death sentence. Yet this hazardous atmosphere is also a data stream. The concentration of CO2 within a cave often breathes in rhythm with the seasons on the surface, providing scientists with a direct measurement of the biological activity and carbon cycle of the ecosystem above, turning a potential danger into a valuable tool for environmental monitoring. Caves often conceal another, more insidious invisible hazard: radon gas. Produced by the natural radioactive decay of uranium present in many types of rock, radon seeps upward from the deep earth. On the surface, it harmlessly dissipates into the atmosphere. But within the enclosed, poorly ventilated spaces of a cave, it can accumulate to dangerously high concentrations. Odorless, colorless, and detectable only with specialized instruments, radon is a known carcinogen, and long-term exposure poses a significant health risk for dedicated cavers and geologists. This very same gas, however, is now being harnessed as a critical form of geological intelligence. Because radon is released from rock under tectonic stress, scientists in seismically active regions like Japan, Italy, and California are now monitoring radon levels in deep wells and cave systems as a potential precursor to earthquakes.
A sudden spike in radon emissions can be an early warning signal that the Earth's crust is straining, providing a potential, though not yet perfectly reliable, method for short-term earthquake forecasting. In this context, radon transforms from a silent threat into a silent storyteller, a radioactive trace gas carrying vital secrets about the immense and destructive forces building deep within the planet. In contrast to these invisible elements, the most visible formations within a cave, the stalagmites, are also its most eloquent historians. These towers of mineral that rise from the cave floor are built with an almost unimaginable patience. Each drop of water falling from the ceiling leaves behind a microscopic crystalline trace of dissolved calcite. Over centuries, these infinitesimal layers accumulate, building cones, spires, and massive columns that can rival ancient trees in size. But their true value lies not in their beauty, but in the information they contain. Each of these thin layers is a high-resolution snapshot of the world above. By analyzing the oxygen and carbon isotopes within the calcite using mass spectrometers, paleoclimatologists can reconstruct past temperatures, rainfall patterns, and even the character of the vegetation on the surface with incredible precision.
A single stalagmite can contain a continuous climate record stretching back hundreds of thousands of years, revealing ancient droughts, the rhythm of ice ages, and the shifting patterns of phenomena like the El Niño Southern Oscillation. This data is not an academic curiosity. It is the raw information used to build and validate the global climate models upon which critical international policy decisions are based. These formations have even captured the fingerprint of human history, with layers showing deposits of lead pollution from Roman-era mining 2,000 years ago. They are not static sculptures, they are stone archives, silent, irrefutable witnesses to the long story of our planet's climate and our own species' growing impact upon it. The chemistry of the subterranean world not only builds and shapes, but also paints its creations with a palette derived from the very heart of the Earth. Not all cave walls are a monotonous gray or brown. In many systems, they are transformed into vast natural murals. As groundwater percolates through different geological strata, it dissolves a host of minerals, carrying them into the cave system and depositing them onto the rock. Each mineral leaves behind its own unique chromatic signature. Iron oxides produce a spectrum of rich, earthy colors, from deep, visceral reds to vibrant oranges and yellows. The presence of copper can stain entire walls in ghostly shades of blue and green, while manganese leaves behind intricate, black dendritic patterns that resemble delicate calligraphy painted on stone. For a mineral exploration geologist, these colors are far more than mere decoration. They are direct visual indicators of the surrounding region's ore potential. A natural mel wall streaked with the telltale green of malachite is essentially a natural borehole, an exposed cross-section of a potential copper deposit, providing invaluable prospecting data without the need for expensive drilling. For ancient humans who first ventured into these spaces by firelight, such colors must have seemed profoundly mystical, evidence of a divine or spiritual presence within the earth, turning these chambers into some of humanity's first and most awe-inspiring sanctuaries. In the rarest of these subterranean galleries, the walls themselves can come alive with an inner light. This is the phenomenon of fluorescence and phosphorescence, where certain minerals absorb energy from a light source and then re-emit it, sometimes as a brilliant flash of color, other times as a soft, lingering afterglow. When explorers illuminate these chambers with powerful lamps and then extinguish them, the walls can continue to shimmer for several moments, as if the rock itself has inhaled the light and is slowly exhaling it back into the darkness.
Other minerals are fluorescent, remaining inert under normal light, but blazing forth in spectacular vivid colors, electric blues, fiery oranges, and intense greens when exposed to ultraviolet light. This transforms an ordinary-looking passage into a hidden psychedelic landscape. This natural phenomenon is not just a curiosity. It is a direct link to modern technology. The rare earth elements that create some of the most brilliant fluorescence are critical components in advanced electronics, from smartphone screens to high-efficiency LED lighting. Furthermore, astrobiologists are developing remote sensing technologies that use powerful lasers to detect the fluorescence of minerals and potentially organic compounds on the surface of Mars. The glowing caves of Earth serve as perfect natural laboratories for testing the very instruments that may one day detect the building blocks of life on another world. Most caves are formed by the gentle, patient work of carbonic acid. Some of the planet's largest and most complex systems are carved by a far more aggressive and potent force, sulfuric acid. This dramatic process occurs when hydrogen sulfide gas, often originating from deep petroleum reservoirs or geothermal activity, rises and mixes with oxygenated groundwater near the surface. The resulting chemical reaction produces sulfuric acid, a corrosive agent powerful enough to dissolve limestone at a shockingly rapid rate, carving out colossal chambers and labyrinthine passages on a scale that dwarfs typical water-formed caves. The world-renowned Carlsbad Caverns in New Mexico is a prime example of such a sulfuric acid speleogenesis system. The walls of these caves bear the unique chemical scars of their violent creation, scalloped, sponge-like textures, and massive deposits of secondary minerals like gypsum. The presence of these cave systems is often a geological signpost, indicating the potential for significant oil and gas deposits in the region, linking these natural wonders directly to the global energy economy. Moreover, they host some of the most alien ecosystems known to science. They are home to extremophile bacteria that do not rely on sunlight or organic matter, but instead metabolize sulfur compounds directly, eating the rock and the acidic water itself. These chemosynthetic life forms are a primary focus for astrobiologists, providing a compelling model for how life might survive in the sulfur-rich atmospheres of planets like Venus. Finally, we venture into one of the strangest and most dynamic of all subterranean environments, the salt cave. Formed within vast underground deposits of halite left behind by the evaporation of ancient seas, these caves are fundamentally different from their limestone counterparts.
Salt is not a rigid, brittle rock. Under immense geological pressure, it behaves like a plastic, capable of flowing and deforming over time in what are known as salt glaciers. This means the walls of a salt cave are not static. They are in a state of constant, imperceptible motion, creeping, shifting, and reshaping themselves over decades. Because salt is highly soluble, these caves can also be formed and destroyed by water with astonishing speed. Their interiors often shimmer with a crystalline beauty, featuring delicate, frost-like growths of salt that seem otherworldly. But the geological structures that host them, salt domes, are of immense strategic and economic importance. These domes are impermeable, and as they push up through other rock layers, they create perfect traps for oil and gas, making them a primary target for the fossil fuel industry. Furthermore, the plastic, self-healing nature of salt formations makes them the world's most secure locations for long-term waste storage. The United States Strategic Petroleum Reserve is held in vast man-made caverns within salt domes. And the nation's only deep geological repository for nuclear waste, the Waste Isolation Pilot Plant, is located in a salt bed in New Mexico, relying on the rock's ability to slowly flow and entomb the hazardous material forever.
These strange, creeping caves are part of a geological system that is central to both energy security and the profound challenge of nuclear containment. Beyond the grand visual spectacle, caves function as meticulous, microscopic archives, preserving not just the forms of the past, but the very essence of its environment. Within the crystalline structure of cave formations, tiny bubbles of ancient atmosphere are trapped, sealed away from the world for thousands or even millions of years. As calcite precipitates layer by layer to form a stalagmite, it envelops pockets of the cave air, creating a flawless time capsule. Using advanced laser ablation techniques and mass spectrometry, scientists can now pierce these microscopic bubbles and directly analyze the atmospheric composition of Earth's deep past. This is not merely a climate record, it is a window into the fundamental conditions that shaped life itself. This data allows us to answer critical questions in paleobiology. What was the precise oxygen level that fueled the age of the dinosaurs? How did carbon dioxide concentrations fluctuate during the Great Extinction events? While polar ice cores provide a high-resolution atmospheric record for the planet's frozen regions, these speleothemes, the calcite formations in caves, offer the only comparable data from the temperate and tropical zones, providing a truly global picture. Holding a cross-section of a stalagmite is like holding a fragment of a prehistoric sky, a whisper of the air our planet once breathed, kept safe in stone until modern science could finally unlock its secrets. The rocks themselves hold another, more mysterious record, an archive not of air, but of the planet's invisible and vital magnetic field. Hidden within the stone of many caves are magnetic minerals, such as magnetite, whose microscopic particles behaved like tiny compass needles as the rock was forming. At the moment of their lithification, they aligned themselves with the Earth's magnetic field, creating a permanent frozen record of its direction and polarity. By studying these frozen compasses from different geological eras, scientists can reconstruct the long, dramatic history of our planet's magnetic field, including its periodic and chaotic reversals, where the magnetic north and south poles completely flip. This is not an academic exercise, it is a matter of planetary security. The magnetic field is our primary shield against the constant bombardment of deadly solar radiation and cosmic rays. Understanding its historical cycles of weakening and flipping is critical for predicting the effects of the next reversal on our technologically dependent civilization. A weakened field could cripple global satellite networks, devastating GPS, communications, and financial systems, and dramatically increase radiation levels on the surface. The study of paleomagnetism in the quiet darkness of a cave is, in essence, a critical component of our planetary defense strategy, helping us prepare for a global disruption that is not a question of if, but when. From the inorganic records of the past, we transition to the preserved remnants of ancient life. Long before the evolution of complex animals, Earth was the domain of microorganisms. In the stable, anoxic, and dark environment of caves, the conditions are sometimes perfect for preserving the delicate fossilized remains of these earliest forms of life. Trapped in mineral deposits, these microscopic fossils offer scientists priceless glimpses into the planet's primordial biology. But their significance has taken on a new urgency in the age of space exploration. These fossils represent exactly the kind of evidence astrobiologists are searching for on Mars. They are the search image for life in a rock-based, nutrient-poor, light-deprived environment. The discovery of a fossilized microbial filament in a Martian rock sample would likely mirror the very structures found preserved in the ancient darkness of Earth's caves. These subterranean spaces are therefore not just museums of terrestrial life, but training grounds for the search for extraterrestrial biology, teaching us what to look for and how to recognize the subtle fingerprints of life on other worlds.
The overall most profound revelation from the subterranean realm is that life can flourish there now, in the present, on a massive scale, completely divorced from the sun. When we imagine an ecosystem, we instinctively picture sunlight as its energetic foundation. Yet deep inside caverns, where not a single photon of light has ever penetrated, entire communities of complex creatures exist, supported by energy sources completely alien to the surface world. This is the science of the dark food web. In some systems, the base of the food chain is detritus, nutrients carried into the cave by water, or, most importantly, the guano from vast colonies of bats that roost in the upper chambers. This guano is a massive energy import, fueling a thriving economy of fungi, bacteria, and insects. In other, even more isolated caves, life subsists via chemosynthesis, feeding on microbial films that grow directly on the stone, deriving energy from chemical reactions with minerals like iron and sulfur. The biodiversity built upon these foundations is astonishing. Blind insects with elongated antennae, colorless crustaceans, ghostly white salamanders, and spectral fish that have completely lost their eyes over countless generations. These ecosystems are masterpieces of efficiency, thriving in an environment of extreme energy scarcity. They are now being studied as models of sustainability and closed-loop systems, offering insights into how life can persist with minimal resources, a lesson of increasing relevance for our own species. Furthermore, the constant low-level chemical warfare between microbes in this competitive environment has spurred the evolution of unique biochemical compounds, making these dark ecosystems a new frontier for bioprospecting, the search for novel molecules that could become the next generation of life-saving antibiotics. The inhabitants of these dark ecosystems are living testaments to the power and precision of natural selection. In the sunless waters that flow beneath the ground, eyes are not just unnecessary, they are a biological liability, an energy-intensive organ in a realm where energy is the most precious currency. Over countless generations, fish living in caves have undergone a process of regressive evolution, systematically losing their vision. Their eye sockets shrink, become covered by skin, or vanish entirely. Their bodies, lacking any need for camouflage or sun protection, become pale and almost translucent. But this is not a story of loss. It is a story of radical reallocation of resources. The neurological and metabolic energy once dedicated to vision is rechanneled to develop extraordinary sensitivity in other senses. These fish can detect the faintest vibrations through their lateral lines, effectively feeling their surroundings with their entire body. They trace minute chemical signals in the water, navigating and hunting with a precision that sight could never offer in the dark. This evolutionary trade-off has made them invaluable subjects for medical science. The Mexican tetra, which exists in both eyed surface-dwelling and blind cave-dwelling populations of the same species, has become a key model organism for understanding human eye disease. By studying the genetic switches that turn off eye development in these fish, researchers are gaining critical insights into the pathways that lead to conditions like macular degeneration and retinitis pigmentosa, hoping to find ways to reactivate or preserve sight in humans. This same evolutionary logic applies to the ghostly crustaceans that inhabit these subterranean streams. Shrimp-like and crab-like creatures, long ago isolated from the surface world, have also abandoned eyes altogether. They have evolved into exquisitely sensitive navigators of the dark,
With elongated, spindly limbs and antennae so hypersensitive, they can construct a detailed three-dimensional map of their environment from vibrations and water currents alone. Their appearance across the globe is a textbook example of convergent evolution. Completely unrelated species in isolated caves on different continents have independently evolved the exact same set of adaptations: blindness, albinism, and heightened sensory perception, because they all face the identical environmental pressures of darkness and scarcity. Beyond their evolutionary significance, these creatures are now recognized as critical bioindicators. Their extreme adaptation to a stable, pristine environment makes them incredibly vulnerable to pollution. The health and numbers of a cave crustacean population serves as a direct and highly sensitive early warning system for groundwater contamination, the proverbial canary in the coal mine for the aquifers that supply drinking water to millions. Not all residents of the dark are blind. Some, like the bat, are masters of a different kind of sight. For many species, caves provide the perfect roosting environment, safe from predators, dark, and with a stable temperature. Their method for navigating the absolute blackness both inside and outside the cave is echolocation, nature's original and arguably most sophisticated sonar system. Bats emit a continuous stream of high-frequency calls, far above the range of human hearing, and then their exquisitely tuned ears and brains analyze the echoes that bounce back. From the timing, direction, and texture of these reflections, they build a rich, detailed, real-time mental map of their surroundings, a map so precise they can track and intercept a mosquito in mid-flight. The study of this biological sonar has directly inspired advancements in human technology, from the sonar systems used by nuclear submarines to the radar that guides aircraft and the medical ultrasound machines that allow us to see inside the human body. Furthermore, the economic importance of these vast bat colonies is staggering. A single colony can consume several tons of insects in a single night, providing a free, natural, and highly effective pest control service for agriculture that saves the industry billions of dollars annually. In some of the world's most enchanting caves, life itself becomes the source of light. In caverns in New Zealand and Australia, ceilings sparkle as if inlaid with a fallen constellation. This magical luminescence comes from glowworms, the larvae of a species of fungus gnat, which emit a cold, blue-green light through a biochemical process called bioluminescence. They dangle sticky silk-like threads from the ceiling and use their glow to lure in other small insects, which are drawn to the faint light, mistaking it for the moon or an exit. This natural light production, driven by the reaction of chemicals luciferin and luciferase, is incredibly efficient. Scientists have now harnessed the genes for these proteins for use as reporter genes in cutting-edge biomedical research. By attaching the light-producing gene to a cancer cell or a virus, researchers can make these pathogens glow, allowing them to track the precise spread of a disease through a living organism in real time. The otherworldly beauty of a glowworm cave is directly connected to the forefront of the fight against cancer. Perhaps the most mythical of all cave dwellers is the olm, a pale, serpentine salamander found in the subterranean streams of Europe. With its translucent, pigmentless skin and slender body, it looks almost ghostly. The olm is a master of survival, having adapted to its nutrient-poor environment by slowing its metabolism to an extraordinary degree. It can live for over a century and can survive for up to a decade without a single meal. Legends once described them as baby dragons washed up from the underworld. Today, they are a primary focus for scientists studying longevity and the biology of aging.
Their remarkable ability to slow the aging process and regenerate lost limbs holds profound secrets that could one day lead to breakthroughs in human regenerative medicine and health span extension, turning this baby dragon into a potential key to our own longevity. At the absolute foundation of these complex dark ecosystems are organisms that defy our most basic assumptions of life. Far from sunlight, in the deep earth, thrives a class of microbes that performs a seemingly impossible feat. They eat rock. These are chemoautotrophs, bacteria that derive their energy not from photosynthesis or organic matter, but directly from inorganic minerals. By metabolizing compounds of iron, sulfur, or manganese, they unlock the chemical energy stored within the very walls of their environment, forming the primary producer layer of a food web that is completely independent of the sun. These microbes form delicate, shimmering mats and biofilms on cave walls, subtly altering the geochemistry of the entire system as they live and die. This is not merely a biological curiosity. It is a gateway to revolutionary technologies. The genetic machinery that allows these organisms to leach minerals from solid rock is now being harnessed for industrial applications like biomining, a process where microbes are used to extract valuable metals like copper and gold from low-grade ores, offering a far more environmentally benign alternative to toxic cyanide-based methods. The overall mood of natural selection takes its own unique and divergent paths, creating species found in no other habitat on Earth. Entire lineages of fish, insects, spiders, and amphibians exist solely within a single cave or a specific interconnected karst system. These organisms are known as endemics, and some are so geographically restricted that their entire global population lives within a single chamber, making them among the rarest and most vulnerable creatures on the planet. Their existence has profound implications for international policy and national sovereignty. Under the United Nations Nagoya Protocol on Access and Benefit Sharing, the unique genetic resources of a nation's flora and fauna are its sovereign property. This means a rare endemic cave beetle in the karst landscapes of Vietnam, for example, is not just a biological marvel, it is a national genetic asset. If a foreign pharmaceutical company were to discover a life-saving compound derived from this beetle, Vietnam would be legally entitled to a share of the profits. This transforms the conservation of these fragile species from a purely environmental issue into one of economic and national security, turning these subterranean biodiversity hotspots into closely guarded vaults of genetic wealth. A single act of pollution or careless tourism could not only cause an extinction, but could also erase a potential multi-billion-dollar medical or technological breakthrough.
Nowhere is this potential more apparent than in the urgent global search for new medicines. In 2012, scientists exploring a remote cave system made a discovery that sent shockwaves through the medical community. They isolated a strain of bacteria that had never been exposed to human-made pharmaceuticals, yet was naturally resistant to nearly every class of antibiotic known to science. These microbes, locked in a state of perpetual, low-level chemical warfare with other microorganisms for millions of years, had evolved an arsenal of sophisticated defense mechanisms. This finding comes at a critical moment in human history. The World Health Organization has issued dire warnings about the growing crisis of antibiotic resistance, predicting a near-future post-antibiotic era where routine infections and minor surgeries could once again become life-threatening. The ancient, isolated ecosystems within caves are now seen as one of the last best hopes for discovering novel antibiotic compounds that resistant superbugs have never encountered. This has launched a new age of bioprospecting, where research teams venture into these extreme environments in a high-stakes hunt for life-saving molecules. What appears to be a sterile, barren cave wall may in fact be a living library of molecular secrets, a silent battleground where the weapons forged over eons of microbial conflict could one day save millions of human lives. Even the more familiar inhabitants of this dark world hold astonishing potential. In the deep shadows of cave ceilings, certain species of spiders, also adapted with pale coloration and long spindly legs, weave sprawling, complex webs that can stretch for yards across entire chambers. These are not the delicate temporary orbs of their surface-dwelling cousins. They are robust, semi-permanent nets engineered for maximum coverage and durability in an environment where prey is rare and must be intercepted.
The silk these spiders produce is of intense interest to material scientists. All spider silk is renowned for its combination of strength and elasticity, but the silk from these cave dwellers, adapted for performance in a high humidity, stable environment, has unique properties. This is the field of biomimicry, studying nature's designs to inspire new human technologies. Scientists are working to replicate the genetic code for producing this silk in order to mass produce it for revolutionary applications, including biodegradable surgical sutures stronger than steel, lightweight bulletproof vests, and advanced composite materials for the aerospace industry. The humble, patient hunter, waiting silently in the darkness, may hold the key to the next generation of advanced materials. Its silken trap, a blueprint for technologies we are only just beginning to imagine. For untold millennia, these subterranean worlds existed in a state of pure geology and biology. But then a new force entered the darkness, a creature that did not merely adapt to the environment, but sought to understand and reshape it. This was the dawn of humanity, and the cave became our first sanctuary, our first canvas, and the first stage for the unfolding drama of human consciousness. Long before the invention of written language, long before the first cities were built, our ancestors decorated the deep, silent walls of caves with art of astonishing sophistication. For many years, the scientific narrative centered on the magnificent paintings of Lascaux and Chauvet in Europe. But recent discoveries in Southeast Asia have fundamentally challenged this Eurocentric view of history. In the limestone karsts of Sulawesi, Indonesia, archaeologists have dated depictions of wild pigs and hand stencils to more than 45,000 years ago, making them some of the oldest figurative artworks ever found.
The overall mood is not crude etchings. They are powerful, evocative expressions from a fully modern human mind. They are the earliest surviving evidence of the great cognitive leap. The moment our species began to think symbolically, to tell stories, to imagine. To stand before them is to connect directly with the minds of these ancient artists who carried flickering torches into the planet's deepest galleries to record their world. The stable, protected environment of the cave preserved their creations, shielding them from the ravages of time and weather. We will never know their exact purpose. Were they hunting magic, clan histories, or shamanistic visions? But their meaning is clear. The cave was not just a shelter, it was the birthplace of the human imagination. For tens of thousands of years, these spaces provided the safest and most reliable refuge on a dangerous planet. They offered a defense against predators, a respite from brutal storms, and a naturally insulated environment, cooler in the summer, warmer in the winter. The archaeological record from this period is written in the stratified layers of cave floors, a history book that can be read with a trowel and brush. Excavations across the world reveal the intimate details of daily life. Stone hearths still holding the charcoal of the last fire, scatters of flint flakes from tool manufacturing, and the discarded bones from countless meals. Nowhere is this record richer than in Southeast Asia, and specifically in Vietnam. The famous archaeological cultures known as Sonvi and Huabin are defined almost entirely by the artifacts discovered within the limestone caves of provinces like Longsern, Thanghua, and Ningbin. These sites show layers of continuous or recurring habitation stretching back over 20,000 years, documenting the slow transition of human societies from nomadic hunter-gatherers to more settled communities.
A natural male narrator voice is to stand into one of these caves today, is to stand in the living room of our most distant ancestors, a place where smoke once curled towards the stone ceiling, where tools were crafted, and where the first chapters of Vietnamese prehistory unfolded in firelight and shadow. These subterranean archives preserve more than just the story of humanity. They act as natural traps and time capsules for the other inhabitants of their world. Within their cool, protected chambers, the skeletons of extinct animals have been discovered in remarkable states of preservation. But the cast of characters changes depending on the continent. While European caves hold the remains of woolly mammoths and cave bears, the caves of Southeast Asia tell a different, equally fantastic story. They have yielded the bones of the giant ape Gigantopithecus, the largest primate that ever lived, the ancient elephant-like Stegodon, and giant tapirs. These discoveries are our primary window into the lost megafauna of the region. They are natural museums curated by the Earth itself. But they are also crime scenes. The bones often bear the telltale cut marks from stone tools and are deliberately broken to extract the nutritious marrow, providing irrefutable evidence of our ancestors' prowess as hunters. These caves were not just graveyards where animals wandered in to die. They were butcheries and larders where early humans processed their kills, demonstrating their ability to hunt and dominate creatures many times their size. Crucially, caves preserve the story not just of our own species, Homo sapiens, but also of our evolutionary cousins. While Europe was the heartland of the Neanderthals, Asia was home to other archaic humans. The caves of this continent are now providing the missing chapters in the human story.
Fossils of the ancient hominin Homo erectus have been found here for decades. More recently, a single finger bone and a few teeth from a cave in Denisova, Siberia, revealed an entirely new branch of the human family tree, the Denisovans. Through genetic analysis, we now know that while the Denisovans are physically extinct, their DNA lives on, especially in the modern indigenous populations of Southeast Asia and Oceania. The caves of Asia are the key to understanding these mysterious relatives. They were not brutish, primitive beings. They crafted tools, likely had complex social structures, and thrived in harsh Ice Age climates. Standing inside a cave in the Annamite Mountains, one is confronted with a profound possibility. This very space may have once been a shelter not just for our ancestors, but for another kind of human, a different intelligence whose story was almost completely lost to time, waiting in the darkness to be rediscovered. As human societies grew more complex, so did their relationship with the subterranean world. The cave transitioned from a simple physical shelter for the living into a profound spiritual portal for the dead. Across ancient cultures, the darkness, permanence, and depth of caverns made them natural gateways to the afterlife, sacred resting places where the spiritual world felt tangibly close. Archaeologists have discovered elaborate burial sites deep underground where bodies were carefully placed, often accompanied by offerings of tools, pottery, and personal ornaments intended for use in the next life. The stable, protected environment of these cave tombs has resulted in a level of preservation that is simply impossible in open-air sites. Nowhere is this more striking than in the unique tradition of boat coffin burials found in caves throughout Southeast Asia. In these rituals, the deceased were placed within massive, hollowed-out logs resembling canoes, which were then interred in high, inaccessible grottos. This practice suggests a sophisticated belief system centered on a final journey, a voyage through the underworld, with the cave serving as the eternal, silent harbor. The exceptional preservation within these sites provides physical anthropologists with an invaluable record, offering intimate details about the health, diet, and lives of people from millennia ago. The silence within these chambers feels profound, not as an emptiness, but as a space still resonant with the ancient rituals of grief, reverence, and humanity's eternal search for meaning in the face of mortality. Throughout history, the inherent secrecy and defensibility of caves have also made them ideal hiding places. They have served as natural, untraceable vaults for treasures, relics, and secrets of immense value. The most famous example of this is the discovery of the Dead Sea Scrolls, ancient manuscripts that reshaped our understanding of religious history, preserved for nearly 2 millennia in the dry caves of the Judean desert. But the concept of treasure is not limited to gold or ancient texts. In the context of modern history, it can mean something far more critical: the very means of survival and resistance. During the devastating conflicts of the 20th century in Vietnam, the nation's extensive network of karst caves became a strategic asset of monumental importance. Entire regiments of soldiers sheltered from aerial bombardment within them. They were transformed into highly secure command centers, munitions depots, and, most remarkably, fully functioning underground hospitals, such as the famous facility hidden within the limestone karsts of Ha Long Bay. For the soldiers and civilians who lived and worked within them, these caves were the ultimate treasure, a sanctuary that allowed them to endure.
The overall mood is left behind a darker, more dangerous legacy. Today, many of these same caves conceal a different kind of hidden artifact, unexploded ordnance. The romantic notion of treasure hunting is replaced by the lethal reality of demining operations, a stark reminder that the subterranean world holds not just the secrets of the ancient past, but also the deadly, lingering consequences of modern warfare. Beyond their use in death and war, caves have been revered across cultures as sacred spaces, natural temples infused with divine presence. The cool silence, echoing grandeur, and separation from the mundane world made them perfect for worship and meditation. While magnificent rock-cut temples were carved into cliffs in India and hidden chapels were established in European caverns, Vietnam boasts one of the world's most vibrant and living traditions of cave worship. Here, a powerful spiritual synthesis has occurred, blending the awe-inspiring geology of the karst landscapes with the profound tenets of Buddhism. Instead of building temples near caves, the Vietnamese built them within them. The Perfume Pagoda near Hanoi is not a single structure, but a vast complex of shrines and temples built into a labyrinth of grottos, attracting millions of pilgrims each year. At Tam Kok Bik Dong in Ninh Binh, visitors row boats through a submerged cave system to reach pagodas nestled at the base of limestone cliffs. In these spaces, the natural stone formations, the stalactites and stalagmites, are not seen as mere geology, but as sacred iconography, integrated into the spiritual architecture. The cave is not just a container for the temple, the cave is the temple. This enduring practice is a powerful testament to the human instinct to find the divine within the deepest, most mysterious chambers of the earth. Amidst the art, the bones, and the altars, caves preserve another, more intimate and haunting trace of our ancestors: the ghostly outlines of human hands. Pressed or painted onto stone walls tens of thousands of years ago, these handprints represent one of the most direct and personal connections we have to the prehistoric past.
Often created by placing a hand flat against the rock and blowing pigment around it, leaving a negative silhouette, they are a chorus of ancient presence. Tiny prints from children are found alongside those of adults. Scientists debate their meaning. Were they a signature, a ritual gesture, a claim of belonging? Whatever their intent, their power is universal. This was not a depiction of an animal or a hunt. This was a statement of the self. It is the oldest, most fundamental assertion of identity. I am. I was here. Modern forensic analysis of these prints can reveal the age and sometimes even the sex of the individual. In some caves, the stencils show hands with missing fingers, sparking debate among archaeologists about possible ritual amputation or the harsh realities of Ice Age life. To place your hand within the outline of one of these ancient prints is to feel an electric connection across an unimaginable gulf of time, a shared moment of humanity with an individual who stood in that exact spot in the flickering firelight and chose to leave a permanent trace of themselves against the coming darkness.
The brilliant and powerful art of the ancient world was not created with ease. It was born in a challenging, hostile environment of absolute darkness, made possible only by humanity's mastery of its first great technology, fire. Archaeologists have found the physical proof of this illumination scattered on cave floors, the blackened remnants of charcoal from ancient fires, and the oily soot from primitive animal fat lamps that still stain the stone ceilings. These fires would have crackled and smoked, their flickering, unstable light casting dancing shadows across the uneven walls. This dynamic lighting may even have been a deliberate part of the artistic experience, creating an illusion of movement in the painted animals, bringing the hunt to life in a hypnotic, cinematic display. But for modern science, these humble charcoal fragments are far more valuable than the light they once produced. They are perfect time capsules for radiocarbon dating. By measuring the decay of the carbon-14 isotope within the charcoal, scientists can determine its age with remarkable precision, allowing them to assign a definitive timeline to the paintings and the layers of human occupation. This technique transforms a simple campfire remnant into a chronological anchor, the very key that unlocks the deep prehistory of our species. Furthermore, by analyzing the cellular structure of the charcoal itself, researchers can identify the type of wood that was burned – pine, oak, juniper – and thus reconstruct the ancient forest ecosystems that existed in the world outside the cave tens of thousands of years ago. The stable, protected environment of caves acts as a perfect natural museum, preserving the tools of our ancestors with a fidelity that is almost miraculous. While organic materials like wood and bone quickly decay on the surface, the constant temperature and humidity of a cave can preserve them for millennia in near-perfect condition. Archaeologists have uncovered stone scrapers, bone awls, and even wooden spear shafts lying as though their owners had only just set them down. But modern science allows us to see far beyond the object itself. Using powerful scanning electron microscopes, a discipline known as microwear or use-wear analysis can examine the microscopic scratches, fractures, and polish on the edge of a stone tool. This forensic approach reveals, with irrefutable certainty, precisely how the tool was used. The signature of cutting meat is different from that of scraping animal hides, which is different from carving wood or harvesting silica-rich plants. This allows us to move beyond speculation and into the reality of daily prehistoric life. By finding not just the finished tools, but also the waste flakes, hammerstones, and raw material cores, archaeologists can reconstruct the entire chaîne opératoire, the operational sequence or thought process of the ancient craftsperson.
The cave preserves not just the final product, but the intellectual blueprint of the mind that conceived and created it, providing a direct window into the cognitive abilities of our ancestors. Alongside the artifacts of human ingenuity, caves create their own geological jewels. In certain pools of mineral-rich water, an astonishing process unfolds, resulting in the formation of cave pearls. Unlike the pearls of an oyster, these are entirely geological in origin. They begin when a tiny nucleus, a grain of sand, a bat bone fragment, a piece of rock, becomes agitated in a shallow pool fed by steadily dripping water. The constant swirling motion prevents the nucleus from cementing to the floor. As each drop of calcite-rich water enters the pool, it deposits a microscopic crystalline layer around the nucleus. Over centuries, thousands of these concentric layers build upon one another, forming a smooth, polished, and often perfectly spherical pearl.
A natural male narrator with a warm, friendly tone. These natural processes are a perfect analog for advanced industrial techniques like pharmaceutical tablet coating and agglomeration. The fluid dynamics of these simple pools have been studied to understand the principles of uniform, concentric layering, a manufacturing process that nature perfected millions of years before humanity. Like their larger cousins, the stalagmites, the layers of a cave pearl also contain an isotopic record of the environmental conditions at the time of their formation, a tiny rolling archive of the cave's chemical history. From these miniature jewels, we return to the realm of the colossal. Just as the Earth can build with microscopic patience, it can also achieve a scale that dwarfs our most ambitious engineering. In Oman's Majlis al-Jinn cave, or meeting place of the jinn, hangs the largest known freestanding stalactite in the world. It is a single monolithic icicle of stone, plunging more than 60 meters, nearly 200 feet, from the ceiling in the darkness. To stand beneath it is to be humbled by a structure of almost inconceivable weight and fragility, a skyscraper-sized dagger of calcite suspended in the void. It was formed by the same simple process as all stalactites, the patient deposition of calcite from dripping water, but amplified over hundreds of thousands of years in a chamber of immense size and stability. Its existence is a miracle of natural structural engineering. It is a massive, self-constructed cantilevered beam that must support its own colossal weight against the constant pull of gravity. The sheer scale and remoteness of such features make them objects of national pride and intense logistical challenges. Access to Majlis al-Jinn is not a simple walk. It requires a highly technical 160-meter free rappel descent through a hole in the desert floor, an endeavor possible only for the most elite explorers and scientists. This colossal formation is a silent, powerful testament to the fact that the Earth's slow, creative rhythms, working patiently in the dark, can produce marvels of engineering far beyond the scope of our own fleeting ambitions. While nature stands as the supreme architect of the subterranean, humanity, in its relentless pursuit of resources, has also become a prolific creator of vast underground spaces. Salt mines, in particular, are not merely the cramped tunnels of popular imagination. They often open into colossal man-made caverns that rival the scale of natural caves. Formed by the systematic excavation of ancient salt deposits left by evaporated primordial seas, these spaces are a unique fusion of industrial engineering and raw geological beauty. Their walls, composed of pure halite, shimmer with a crystalline translucence, reflecting light in dazzling hypnotic patterns. The most breathtaking example of this is the Wieliczka salt mine in Poland, a UNESCO World Heritage Site that transcends its industrial origins. Over centuries, the miners themselves carved an entire subterranean city from the salt, including a vast, fully ornamented cathedral, complete with altars, reliefs, and chandeliers hewn directly from the crystalline rock.
But beyond these historical marvels, these man-made caverns represent a new and valuable asset class: subterranean real estate. Their immense size, structural integrity, and naturally stable temperature and humidity make them ideal for a host of 21st century applications. Governments and corporations now use them for the secure, climate-controlled archive of everything from movie films to priceless historical documents.
The overall mood, born from industry, demonstrate how humanity is now circling back to the underground, seeking not just raw materials, but security, stability, and sanctuary in the vast, silent voids we have carved for ourselves. From the industrial present, we journey back to the deep past, preserved within the planet's most fragile and threatened archives, the ancient ice caves. In the world's polar regions and high-altitude glaciers, some caves contain ice that has remained frozen for thousands, even hundreds of thousands of years. This is not ordinary ice. It is a compressed, layered library of Earth's climate history. Each annual layer of snowfall traps air bubbles, dust, and volcanic ash, creating a perfect, high-resolution timeline of the planet's atmosphere. By drilling deep ice cores from these glaciers, often accessed via the caves within them, scientists can directly measure the composition of Earth's past atmosphere, tracking the rise and fall of greenhouse gases and temperatures across the ages. This data is the bedrock of modern climate science. However, these frozen archives are now in a state of catastrophic crisis. As global temperatures rise, these ancient glaciers and the caves they contain are melting at an accelerating rate. The work of glaciologists has transformed into a desperate salvage mission, a race against time to extract and analyze this priceless data before it is liquefied and lost forever. The geopolitical stakes are immense. The Himalayan glaciers, often called the Third Pole, and their internal cave systems are the headwaters for rivers that supply fresh water to nearly 2 billion people across Asia, from China and India to the downstream nations of the Mekong Delta, including Vietnam. The rapid melting of this ice is not just a loss for science, it is a direct and imminent threat to the water security, food supply, and political stability of the entire continent, a looming crisis written in the disappearing blue ice of these silent, frozen cathedrals. While the loss of our planet's ice represents the closing of one frontier, another, far less understood, is just beginning to open: the vast, flooded underworld of underwater cave systems. In the Yucatan Peninsula of Mexico, explorers have connected multiple cave networks to map the Sac-Acton system, the largest known underwater cave on Earth, a sprawling, submerged labyrinth stretching for over 370 kilometers. These are not dark, muddy tunnels. They are corridors of almost impossible clarity, lined with stalactites and stalagmites that formed in the open air during the last ice age when sea levels were hundreds of feet lower. To navigate these passages is to fly through a preserved prehistoric landscape. This is arguably the final frontier of planetary exploration. The environment is more hostile and less forgiving than outer space. Divers must rely on highly specialized technology like closed-circuit rebreathers, which scrub carbon dioxide from their breath, and powerful propulsion vehicles to cover the vast distances. There is no surface, no easy escape, and a single equipment failure or navigational error can be instantly fatal. Yet the allure is irresistible, for these submerged caves are pristine time capsules. The overall mood of a warm, friendly tone, fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.80.
They have preserved the skeletons of extinct Ice Age megafauna, ancient Mayan pottery, and, most importantly, some of the oldest and most complete human skeletons ever found in the Americas. Discoveries like the remains of a teenage girl nicknamed Naya in the Hoyo Negro pit have fundamentally reshaped our understanding of when and how humans first populated the continents. The exploration of these underwater realms is not a sport. It is a high-risk, high-reward scientific endeavor, pushing the absolute limits of human endurance and technology to uncover the deepest secrets of our planet's history, hidden in the silent, crystal-clear waters of a lost world. The ultimate expression of subterranean scale is not measured in length or depth alone, but in sheer, world-altering volume. In the most colossal caverns, the internal environment is so vast that it decouples from the surface, becoming a self-contained planetary ecosystem. We return to Sun Dong in Vietnam, a cave so enormous that it generates its own weather. Here, warm, humid air rising from the immense underground river meets the cooler air near the ceiling hundreds of meters above, causing vapor to condense into mist and form fully fledged clouds that drift through the colossal chamber. Droplets from these clouds fall as a localized rain, nurturing the improbable spectacle of a pristine jungle thriving in the deep earth, growing beneath two massive skylights where the ceiling collapsed eons ago. Thousands of kilometers away, in the Gunung Mulu National Park of Malaysia, lies the Sarawak Chamber. While Sundom holds the record for the largest passage, Sarawak holds the title for the single largest cave chamber on Earth by surface area.
It is a void of proportions, a single uninterrupted room so vast it could comfortably accommodate 70 Boeing 747s parked wingtip to wingtip with space to spare. The discovery and subsequent stewardship of these two mega caves have positioned them as crown jewels of Southeast Asia's natural heritage, key assets in a geopolitical strategy that leverages unique, high-value ecotourism to generate foreign currency and bolster national prestige on the world stage. However, their scale presents an immense conservation paradox. The very act of visiting them, of introducing foreign microbes, artificial light, and changes in carbon dioxide from human breath, threatens the delicate, unique ecosystems that have evolved in isolation for millennia. For the explorers who first entered these spaces, the experience was one of profound, almost terrifying psychological dislocation. In a space so vast that the most powerful headlamps cannot find a wall or ceiling, the human mind struggles to process the scale, leading to a unique sensation of subterranean agoraphobia, an unnerving fear of the immense, silent, and utterly black emptiness. The awe inspired by these spaces is directly proportional to the immense risks taken to discover and explore them. Cave exploration, particularly at its cutting edge, is not a recreational hobby. It is a high-stakes discipline of science and endurance that operates with a risk profile comparable to deep-sea submersion or space travel. And of all its subdisciplines, none is more famously perilous than cave diving. Often cited as one of the most dangerous forms of exploration, it requires navigating flooded passages where the physical and psychological pressures are extreme. In the event of an emergency, a diver cannot simply ascend to the surface. The only way out is back the way they came, which may be a 2-hour journey through a labyrinth of constricting tunnels. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. Visibility can drop to absolute zero in seconds if a fin kick stirs up fine silt from the floor. To mitigate these risks, cave divers operate under a set of rigid, unforgiving protocols.
They practice the rule of thirds with their air supply. 1/3 is used for the journey in, 1/3 for the journey out, and a full 1/3 is held in reserve for emergencies. They live by a philosophy of total redundancy, carrying multiple independent light sources, multiple breathing regulators, and laying multiple guidelines. But no amount of technology can eliminate the immense psychological strain of moving through a cold, dark, and crushingly tight space, totally reliant on your equipment and training, in an environment that allows for zero margin for error. Even for those who stay out of the water, the underground world conceals deadly dangers. Its beautiful, hidden rivers are also its most unpredictable threat. A passage that is dry and safe upon entry can become a raging, flooded tomb with little to no warning. A sudden thunderstorm on the surface many miles away can funnel a massive pulse of water directly into the cave system. Explorers caught in these flash floods may find their only exit route completely submerged in minutes. The roar of the approaching water is often the only warning before a black, debris-filled torrent surges through the stone corridors with unstoppable force. In 2018, the world watched in horror and fascination as this niche danger became a global media event during the Tham Luang cave rescue in Thailand. The trapping of a youth soccer team by a sudden monsoon flood perfectly illustrated the terrifying dynamics of cave hydrology. The rescue required an unprecedented international coalition of military special forces and elite cave divers. It was a 2-week-long battle against rising waters, powerful currents, and near-zero visibility. A mission so complex and dangerous that it pushed the boundaries of human ingenuity and courage. The successful rescue was a testament to human determination, but it also served as a sobering global lesson in the unforgiving power of the subterranean world, a reminder that even in the 21st century, nature's hidden forces always demand our utmost respect. The grand dangers of flash floods and complex rescues often overshadow the intensely personal, moment-to-moment struggle that defines true cave exploration. Many cave systems are not comprised of cathedral-like halls, but of constricted, claustrophobic tunnels that force explorers to crawl, twist, and squeeze through gaps barely wider than their own bodies. In the jargon of the discipline, these tight sections are known as squeezes, and navigating them is a profound test of both physical and mental fortitude. To pass through the tightest passages, cavers must systematically exhale, collapsing their chests just enough to gain a precious inch of clearance, inching forward with solid rock pressing in from all sides. In this environment, panic is not just an emotion, it is a physical trap. The physiological fight-or-flight response, the tensing of muscles, the quickening of breath, can be fatal, wedging a person into the very space they are trying to escape. This requires a level of psychological conditioning akin to that of an astronaut or a bomb disposal expert, a mastery of fear in an environment of extreme sensory deprivation. In the absolute, unyielding darkness, where all external frames of reference are gone, the mind can lose its anchor, blurring the sense of time and distance. The overall mood of subterranean exploration, in an age of remote drones and satellite imagery, it remains one of the last frontiers that demands a human being physically place their body, inch by painful inch, into the great unknown. This inherent risk of disorientation in a three-dimensional maze means that entire expeditions have, in a few tragic cases, vanished forever. With countless branching tunnels, sudden vertical drops, and bewilderingly similar passages, getting lost is a constant and lethal threat. For this reason, cave explorers live by a rigid code of methodical progression and mapping. Every turn is noted, every junction marked with survey flags, because a single wrong turn can lead to hours or days of fatal confusion. When accidents do happen, an injury, an equipment failure, a trapped explorer, the rescue operations are among the most complex and logistically challenging in the world. A subterranean rescue is not a swift extraction. It is a slow, painstaking siege. It involves establishing a chain of underground base camps, running miles of communication wire, and mobilizing teams of dozens, sometimes hundreds of specialists. The process of moving an injured person on a stretcher through a tight or vertical cave system is brutally slow. A section that an unencumbered caver might pass in 10 minutes could take a team of 12 rescuers 8 hours to navigate with a litter. These missions often become major international efforts, requiring diplomatic cooperation to bring in specialist teams from across the globe, turning the fight to save a single life into an act of global humanitarian solidarity. Unlike the surface of the planet, caves cannot be mapped by satellites or aircraft. Every passage, chamber, and shaft must be meticulously surveyed by hand, a process that can take decades of cumulative effort by dedicated teams.
For vast systems like Mammoth Cave, the map is a living document, a multi-generational project that is still not complete. The technology of this craft has evolved from the classic compass, inclinometer, and tape measure to modern laser distance meters, or distos, which provide unprecedented accuracy. Today, the cutting edge of cave cartography involves handheld LiDAR scanners that can generate a photorealistic, millimeter-accurate 3D digital model in minutes. These maps are far more than just navigational aids for explorers. They are documents of critical strategic importance. For hydrologists, they are the blueprints of the aquifers that provide our drinking water. For civil engineers, they are hazard maps revealing the voids beneath our infrastructure. For national security agencies, detailed knowledge of subterranean networks represents invaluable strategic intelligence. The painstaking weekend work of a handful of volunteer cavers can result in data that has profound economic and military significance. Recognizing the immense danger and difficulty of human exploration, the future of this frontier increasingly lies in a partnership between humans and machines. To reach the places that are simply too small, too unstable, or too deep for a person to safely go, scientists have turned to robotics. Remotely operated vehicles swim through flooded tunnels beyond the reach of divers, their sonar painting a picture of passages no human has ever seen. Rugged, crawling robots equipped with advanced sensors inch their way into unstable collapses, assessing risk and searching for new leads. This technology is not only for terrestrial exploration. The lava tubes of Earth are considered a near-perfect analog for the subterranean shelters that future astronauts might use on the Moon and Mars. In preparation, agencies like NASA and private aerospace companies are testing the next generation of autonomous robotic explorers in these very caves. The overall goal is to deploy swarms of small AI-driven drones that can enter a cave system, disperse, map it collaboratively, and return with a complete 3D model, all without direct human guidance. This is not the end of human exploration. Instead, it is a new beginning where robots act as our robotic canaries, our advanced scouts into the most dangerous unknowns, mapping the darkness so that humanity can follow more safely, more efficiently, and more boldly than ever before. Our journey through the subterranean world has taken us from the microscopic drip of water to chambers of impossible scale, from the dawn of human consciousness to the cutting edge of robotic exploration. We have seen that caves are not merely empty spaces beneath our feet. They are a fundamental, active, and profoundly significant dimension of our planet. They represent a new frontier, not of territory, but of depth, resources, and knowledge. In an age where every surface of the Earth is mapped by satellites and contested by nations, the race to understand and control this hidden realm has become a quiet but critical strategic imperative for the 21st century. The vast, pristine freshwater aquifers they contain are becoming geopolitical assets of incalculable value in a world facing increasing water scarcity. The geological processes that create them also concentrate the rare earth minerals that power our modern economies, turning speleological knowledge into a tool of industrial and military advantage. And as we have seen in Vietnam with the careful management of Sondong, these natural wonders have become powerful symbols of national identity and engines for high-value tourism, demonstrating that the greatest treasures are not always extracted but preserved. These spaces are, above all, the planet's great silent archives. They are Earth's memory, holding the raw, unfiltered data of our world's deep history in their very stone and air. While surface landscapes are constantly erased by erosion and weather, the profound stability of a cave preserves a record of unparalleled fidelity. We have learned that stalagmites act as high-resolution climate proxies, their layered growth containing a precise chemical diary of millennia of rainfall and temperature, providing the baseline data that underpins our understanding of future climate change.
We have seen how trapped bubbles of air offer us a direct sample of prehistoric atmospheres, and how magnetic minerals act as frozen compasses charting the chaotic history of the planet's protective magnetic shield. The cave is a library written in the language of chemistry and time, and learning to read it is essential for diagnosing the current health of our planet and forecasting the challenges that lie ahead. To ignore the wisdom held in these stone archives is to navigate into the future with a profound and dangerous amnesia. Beyond the records of a non-living planet, caves are also crucibles of life, radical biological laboratories that force us to redefine our understanding of what it means to be alive. They have proven that entire complex ecosystems can flourish in eternal darkness, completely decoupled from the energy of the sun. These dark food webs, powered by chemical reactions and nutrients from above, are models of extreme efficiency and adaptation. The creatures that inhabit them, the blind fish whose genetics are helping us understand human eye disease, the ancient olm whose longevity may hold secrets to our own aging, the bats whose biological sonar inspired modern radar, are not mere curiosities. They are the products of millions of years of evolutionary research and development. In the urgent global race to combat antibiotic-resistant superbugs, the ancient microbes waging chemical warfare on cave walls represent one of our last best hopes for discovering novel, life-saving medicines. And as we look to the stars, the study of these extremophiles provides a compelling blueprint for the kind of life we might one day find in the subsurface oceans of Europa or the lava tubes of Mars. The cave is a bridge between the deep Earth and the distant cosmos.
The overall mood into the Earth has inevitably become a journey into ourselves. We have discovered that caves were the cradle of human consciousness, the first sanctuary where our ancestors sought refuge, but also the first canvas where they gave voice to their imagination. It was on these stone walls that the human mind took its great leap into symbolic thought, painting the animals of their world and leaving the haunting, personal signature of their own hands, a declaration of existence that echoes across 45,000 years.
These spaces hold the stratified history of our own species, our tools, our fires, the bones of the great beasts we hunted, and the remains of our evolutionary cousins who shared this planet with us. To understand the story of humanity, we must understand the cave, for it was here, in the firelight and shadow, that we first began to ask the questions of who we are and what is our place in the universe. The exploration of this world is not merely a geographic or scientific endeavor. It is an archaeological and philosophical quest into the very origins of our own species. Despite all we have learned, the work has only just begun. The vast majority of the world's caves remain completely undiscovered, their entrances hidden, their passages unmapped. The great mystery endures, a silent, dark continent waiting beneath our feet. And so, our journey through the hidden worlds beneath our feet comes to a close. We began with the simplest of forces, a single drop of water, armed with time, and followed its path to the frontiers of human knowledge. We have stood in the silent, patient presence of geological deep time, where mountains are hollowed out from within and cathedrals of stone are built with imperceptible patience.
We have witnessed the violent, fiery birth of lava tubes, formations that may one day serve as humanity's first off-world shelters. From the microscopic archives of ancient air and planetary magnetism to the colossal voids that generate their own weather, we have learned that the ground beneath us is not a solid, inert mass, but a complex, dynamic, and living system. It is a world of both breathtaking beauty and lethal danger, a realm that has tested the limits of human courage, technology, and our capacity for cooperation in the face of crisis. We have seen that this subterranean dimension is a critical new frontier, a battle space of resources, a library of planetary memory, and a crucible of evolution. We have discovered that the story of the cave is, in the end, the story of ourselves. They are a mirror reflecting our own long journey. In their deepest, darkest chambers, we find the cradle of our own consciousness, the first homes that sheltered us from a hostile world, the first canvases that held the explosive birth of our imagination, and the first sacred spaces where we grappled with the profound mysteries of life and death. The handprints on the wall are not just artifacts. They are a direct message from our deepest past, a declaration of existence that bridges the millennia. The story of our origins is written in these stone halls. In the present, this mirror reflects our modern anxieties and ambitions. The urgent search for new antibiotics within their isolated ecosystems reflects our fear of a future where our medicines fail. The exploitation of their resources, the water, the minerals, reflects our relentless drive for progress, balanced against the critical need for preservation. The climate data held in their formations is a stark, unblinking record of our planet's health and our own growing impact upon it. And finally, these caves reflect our future. The search for extremophile life in their sunless depths informs and guides our search for life on other worlds. The robotic explorers we test in their challenging passages are the prototypes for the machines that will be our emissaries to the stars. The very same impulse that drove our ancestors to carry a torch into the darkness is the same impulse that now drives us to send probes to Mars and beyond. The cave, then, is more than geology. It is a fundamental archetype, a physical and psychological space that has shaped our past, defines our present, and informs the trajectory of our future. The next time you stand on what seems to be solid ground, remember the vast, hidden architecture that lies beneath. The silent rivers, the living ecosystems, the colossal chambers, the patient, unfolding story of a planet and its people.
The Earth has not yielded all its secrets. It waits in darkness and in silence. And as we continue to press into this final frontier, the ultimate question remains: will we enter it with the wisdom to preserve and understand, or merely with the ambition to conquer? The answer to that question will define not only the fate of these hidden worlds, but ultimately our own.